Okay, welcome to a new session. So, in this session, we will discuss the hash table. So, hash table is a data structure that stores key value pairs. This allows fast access to values using keys, ideally of an average time. So, so far we have seen different algorithms for search. We had like linear search. Whenever we had like a list, we were starting searching from the first one and we were going up until the end. We had binary search, and today we study hash table because it is uh, also used to access the data much faster. So the whole point of studying all these data structures and algorithms is to how to manage and store your data in the memory and how to efficiently access to your data and use them. So there are different algorithms to access the data efficiently. Hashtable is one of them. So why do we say that Hashtable is more efficient and quick to access data with the time complexity of O1? Because we store the data in a hash table or an array, and then we access any element in this array using the index. Now, the main question is that how we can get the index, because if we need to go from the first up until the last, that is a linear search. We already studied that, and that was ON, the time complexity, because we had to start from the first and we had to go comparing each element until the last one. So that is when we study the concept of hash function or hash table. Hash function is a function that it gets the the index from this array, and using this index we directly access the data, and that is why we keep the data in a key value pair. So now let me explain from this diagram. Actually, I got this from the presentation which was presented in our class by our professor. So now you see we have, for example, here a value 12 and its key is A. So whenever, first of all, it should be a question for you that how and where in this element, in this array, you keep this value. Like based on which identity or based on which part of this value you like get an index for this one. So generally, if you have a set of data, a set of data that you need to store them in an array. So first of all, you calculate a hash code of each of those data. When you get the hash code for each data, then you divide that by the size of the table. Here it says that modulo table size. So you get the key and then you get the hash code of the key, like for example A. When you get the hash code of this key, then you divide this hash code by the table size. And when you divide by the table size, you get the remainder. That remainder is the index. That is how you get the index. For example, let's suppose you have this object 2, its hash code is 12, and here the table size is 7. So you divide 12 by 7 and the remainder is 5. That means you keep the object 2 in the index 5 here. So next time when you want to access to object 2, so you already get the index through this calculation using this hash function, and when you get the index, so you directly access your element. That is why we call it the time complexity is O1. So, and you keep it like this, for example, here, like this. So it is your first element, second element, and you keep all of them here. However, when you do this, there is a possible or a major problem. And that happens when you get the same remainder. Because when you divide the hash code by the table size, you check the remainder. For example, right now here the hash code is 12, and 12 divided by 7, the remainder is 5. Let's suppose you get another object and the hash code is, for example, 19. If you divide 19 by 7, again the remainder is 5. And when you come here, you see, hey, already there is an element. So that is when the problem happens, and it is called collision. So whenever you want to insert your data into this hash table or into this array, you should have in mind that a collision might happen. So before that happens, you should have your strategy, your plan, and that is you use one of these two approaches: separate chaining or open addressing. In separate chaining, so in each of these slots or locations in the array, you keep them in a linked list order. So for example, if this object 12 and the other one that becomes 19, both of them points to number 5, then you keep them as a linked list. So like just they are pointing to one another, but you only need to have access to the head of that, and you access the head using the index. And the other approach is open addressing. Open addressing is whenever it happens, so it starts looking for the next empty space and then store the new data into that empty space. So in this example, I will focus on the separate chaining. So now instead of directly adding this key value in the array, you make a linked list and keep the linked list in the slots like this, for example. So it can be one of the node, so you keep here. So for example, let's say the hash code of A becomes let's say becomes 13, and our table size is 1 2 3 4 5 6. So if the hash code of A, the key, is 13 and the table size is 6, so 13 divided by 6, the remainder is 1. So that means we need to keep this one here in the second slot like this. So when the next element comes here, you just put that at the end of this list, and you keep adding all those elements that have the same index, and that is how you avoid collision. Otherwise, if you don't do this, when the new node comes, so that just gets replaced. So while doing this, there are three things that you should have in mind. One is the hash function. You should have the idea of what hash function is. The hash function is that how you get the index, and based on that, you know where to put the new element. Of course, you have an array. So array, this hash table is actually an array, and slot. So each index of this array is a slot or a bucket where you keep all those elements with the same index, but as a list. So they should not replace one another. And if you do this, so for each of them you should have a node class, and I already created one node class here. So based on this node that you see, you have a key, you have a value. For example, key is A, the value is 12, and you should have a pointer to the next node. So here, whenever you create the new object, the new node, so you pass the key and value, and initialize these properties. So when you have this node class, now you should have your hash table class. So hash table class, it is actually an array, and when you create an array, so you should know the size of the array. Whenever that means whenever you are creating a hash table, you know you should pass the size of that. So you keep that as a property here. So you have the table size, and you have an array of nodes. You create an array that each type is from this node class. So for that reason, you say node of this table. So whenever you create the object of this hash table, you pass the size of the array and you initialize it, and you initialize your array as well with that table size that you pass. So there are some very important methods that when you insert new elements to this table, you need them. One is the hash function that you need to calculate the index. I gave the name get index. So using this index, like you need to get the hash code and then divide this hash code by the size of the table that you have here, table size, by the size of the table, and the remainder shows the index. So that is the index. For that reason, I gave the name get index. I pass the key to that index, and then I get the hash code of that key hashcode modulo table size. The remainder is your index. So now let's suppose we are inserting this node here. So I created another method for insertion. It is our insertion, public void put or add or insert or whatever name you want to give, but it should be meaningful. So right now it is not here. Let's say I have this node here and I want to store this node inside this array. So how can I do this? So we said that we follow this separate chaining strategy, and now let's see how we can do that. So when we create our add method or put method, so of course we should have two parameters. One should be the key and one should be the value, like we have here. So the first thing, we need to know that which index should we keep this new node, like where should we put that. We cannot start from the head, or we don't know. So based on the calculation that we have here, based on this hash function, we get the index. So first I get the index. I say init index equals get index. I pass the key to that index method. So here I got the index. Let's suppose we say that the index is number 1. So I need to add this here. I need to add this here. But let's see how we can do this. So right now at this point, when I say get index, I just got this index, and I know that I can put this new node here in the second slot. So, and this is empty at the first time, and we already know how to work with linked list, so we should have access to the head of the linked list. That means we should access this slot, and then the first node that comes here, that should be the head. So we already know that we are adding the new node here, and it is the first one, so it should be the head. So I create the head here, node head equals table index. So index, I got that it was the second one, so I stored this second address of this array in the head. So now I have access to this part using the head. So now when I have access to this one, so I add the new node like this. I create the new node that I have based on the key value that I passed to this method. I'm saying new node equals new node key from here and value from here that we pass. So we created the new node. It is our new node. And now we should change this to this address. So we say that this new node dot next equals head, and head is here already. We know from here. New node dot next equals head, and table index, that means this second location, equals to the new node. So that is how we added the new node here. And sometimes, in case you have the same key, not the same hash code, the same key, you should not be adding duplicate. So you should check for that. If it happens that the key is duplicate, you just update the value. So it is how you add a new node in the hash table. And now it is easy for you to search. So here we have the method search. So when you search this, how do you search this? The first thing you should know is that you should get the index, because the search was 01. You get the index using this function. I said index, get index. When you get the index, so here is the linked list, and you need to go through this linked list now. And here is, you already know how to check a linked list. So it is how you go through each node and find the element that you are looking for. You may ask that, well, it looks like a linear search because it is a linked list and you start searching from the first one and go up to the last one. But it is happening very rare, like it happens not all the time. Most of the time you get unique hash code, and that should be your goal, to get the unique hash code. But just in case if it happens, you have these short lists here, and that is a drawback here as well. But still it is much faster in it. And here, for example, you directly get access to the index, and then you have less elements to check instead of starting from the first one and checking up until the last one. So I hope it was informative enough. And just for your information, first I recorded a video while writing these codes, but that was too lengthy, so I did not upload that for you, and I just read the codes. I hope it was clear enough. In case you have any questions, you can always ask and I will answer. Until the next session, have a nice time.